Yeesh. What's up, everyone? I found a little break in the action and decided I need to squeeze in another video. So today's video, I wanted to talk a little bit about the Hardinge turret lathe and the South Bend turret lathe. So I have a heavy 10 South Bend that you probably are familiar with, and I have a lot of turret attachments. I also have a Hardinge DSM 59, and currently it's set up to do a job right now. So I wanted to explain how I set it up, how I did it, show you the actual job running, the cycle time, if you will, and just kind of touch base a little bit on that. It's something I always wanted to do since probably the better part of a year now since I got the Hardinge, and in recent months I've been using it more and more. So usually when a job comes in, there's really not a lot of time to film. It's just a matter of juggling the time and stuff like that. So the job is set up. I've been running some parts on it. I've actually had my son running some parts on it as well. And I just wanted to, talk a little bit about that and talk about another job that's going to be set up on the South Bend. So we'll go over to the lathe and we'll show you what we have all set up right now. So let's talk about the part first that's going to be made. So I have to make 500 of these. All right, and the length of this is overall is 2 inches. The length of the thread is 1 inch, 1.5 inches. The little recess here, or the area that isn't threaded, is 100 thousandths. And the length of this unmachined portion is 400 thousandths. Normal tolerances, plus or minus 5 thousandths on every one. That's a 1/8 of an inch hole that has to go down, if I remember correctly, 1.5 inches. We have a little chamfer up top here, and we just break the edges on either side. So, when you have 500 of something to make, that's where a turret lathe really shines. If you're making 10 of something or 20 of something, by the time you would set up a turret lathe, it's easier to just one-off them on like a conventional lathe, like a little South Bend or something. So let's take a look at the machine now, and I'll show you how I set it all up. So as you can see, we've been running a lot of these parts, and the chips really start to pile up. The material's leaded steel, so it's a 12L14. It makes these long, kind of slinky-like chips that they basically just crumble in your hand. So now what I wanted to do when I set up the job initially was to determine all the different operations that we have. And looking at the piece, we have a chamfer. Actually, let me start from the complete beginning, right? We have to size the piece, right? We need an overall length. Okay, then we have a chamfer. Then we have a turning operation to turn this, to turn the diameter down to get it ready for threading. We have threads, obviously, and we have a hole to drill. So, in order to do that, we need to start with the size. So I created this little stop here, and what that does is, you bring your work up to the stop. You pull the turret in. It presses the work inside the collet to a certain length. You snap the collet shut, and it's ready to go. It is a little bit big, and I'm going to get to how we trim that down. So then the next operation is going to be drilling. So with any hole, you want to start with the center drill. So I have the center drill here, and then I have the actual 1/8 drill right here. So we'll go in, we'll do our center, we'll come over, we'll actuate the turret, and then we'll come in and we'll drill the 1.5 inch deep hole. When we're done with that, then we're going to want to turn the diameter down. So this isn't set, that's why it's pressing in. And then we come in, and then we'll turn the diameter down like so using this turning tool. And then for the next operation is going to be threading. So we get the die head, which this is a geometric die head. It's a 9/16 head. and I believe, yeah, 9/16 is the width of these die chasers. Okay, so you could have like 3/4, and I don't know what the other sizes are. I just know that this is 9/16. We come over, we bring the die head into alignment, and then what I do is I bring it down to slow speed. There's a high and low shift on here. You hear that? We shift it to slow speed. We run the die in. It goes in. It stops, and then it has a little tiny bit of give, a little travel here that it will. Let's see if I can do it. I can't do it. Not with this angle with the camera right here. But anyway, it will go, and the turret will stop, and then this portion of the head will still come out. Maybe I think it has like about 1/8 of an inch of travel, and then once it does that and it hits its own stop, the jaws open up, and then it releases from the work. And at that point, we're ready to face off and put the chamfer on. And I have a tool ground right over here, and I'll show you that now. All right, we're gonna go handheld here as I try to hold the camera and explain this. This edge right here is gonna face the part off, and that edge over there is going to put the chamfer. Obviously the cutting edge is on the bottom of this tool because it's back there on this cross slide. Now this cross slide will move in and out, and it does all the cutting from the underside. And if I was to have a tool over here on the slide, obviously the cutting would be on the top edge of the tool. So during the last operation now, we'll come in, we'll slide it in, and it will face it, and it will put the chamfer on it. And then that brings us to the absolute last operation, and that's going to be parting. So I picked up one of these parting tools, and it bolts directly to the front of the lathe here. Now what I like about this is that it holds the parting tool very close to the edge of the collet here, so it improves the rigidity of this. It parts off like a dream. Obviously, your parting tool has to be sharpened properly, and when it does, it goes right through. So I'll start and I'll part a little bit down, maybe 1/8, 3/16, and I come in with the file and I knock off the burr on this side, and then obviously there's going to be a raised burr over here from where we did the turning operation, and then I'll hit it with the file, so you can handle the pieces. Then we part it off and into the pile it goes. Now there's a lot to these turret lathes. You have a lot of different tool types, and I'm actually surprised at all the different types of tool holders and tools that there are for these. But what you're looking at here is your basic drill holders. They'll either hold drills or spot drills or center drills or whatever. They have these triangle portion that goes in. It's like a little mini V block here, and then the male portion goes in and squeezes it down. If you want to do bigger diameters, like in this one, you could turn this V block opposite. The V points up, and then it just it grabs it on the flat. Let's take a look at our turning tool. Now our turning tool is let me get a better view of the turning tool. These turning tools are pretty unique. If you notice this edge right here, this is where the cutting edge needs to be. This is actually your center line right here. So any tool that you grind, the cutting edge needs to be aligned with the top. Okay, so almost all of my other tools, the cutting edge starts a little bit down because of the constant regrinding, and you're dropping that cutting edge down past the this plane up top here. But these tools are meant to have the cutting edge again right up against this line right here, and the 2 set screws pushes the tool against that face. And over here we shim it if you have a smaller tool. I believe this is a 1/4 inch tool, or maybe this is a 3/8, I think. And how you do this basically is you set it up, and it's just like a boring head. You use an Allen key and you turn it, and it just moves it in and out. And it's one of these things where you need some spare material when you're setting this job up. You know, as you're running them, you know, you're taking a cut and you're basically dialing it in. And as you get closer, as you sneak up to your finished diameter, you know, you could still use the part, but if you go past it, then the part is scrapped. You gotta bring out another piece and then back the tool back out. So, you know, you gotta sneak up onto it, basically the same way as like a boring operation, miking it each time. But once you get it set in, you lock it in place, and then the repeatability is pretty phenomenal. There's another question. You know, how do you turn a shoulder? Let's say you have like a big, huge shoulder that you need to turn. This is where you got to really start getting creative with this stuff. There are no the biggest thing that I can say that I learned about a turret lathe in the past year and a half is that there is no rules. There is no one right way to do this. It's one of those things where whatever you can do to make it work is the correct thing. Now, I'm not saying, you know, you're going to half-ass something and do it, you know, incorrectly. I mean, there are best practices, normal machining practices that you want to follow and that you have to follow. But you know, shimming something, you know, sneaking up on a cut, it's not like another lathe where you could just dial it in, you know, using your dial. It's a lot of measuring, it's a lot of miking, and you know, sneaking up on your measurements. And the same holds true for like how far you're going to come in on your cut. You know, you come in and you're 10,000 shy. How do you measure that? You know, how do you come in? So, you know, you gotta grab an indicator and put it on some part of this turret. You know, you bring the turret to full extension, and then using your stops in the back, you know, you back the stop out, and that will let the turret, you know, move forward or backwards. And with the indicator, you could kind of like start dialing it in. It's this kind of sneak up mentality that you have to master using a turret lathe. But back to the shoulder. So if, you know, let's say you have a 3/4 inch piece of stock and you need to machine it down to, I don't know, a 1/4 inch. You know, you're removing a 1/2 inch of material. So, you know, you could use something called a box cutter, right? A box cutter is basically a cutter with like a built-in follower rest. So it keeps the work pushed up against two rollers, and then you just kind of like just push it right in, and it just shreds the material off, which is really nice. But with let's say normal turning tools, you might need 2 or 3 of them, you know, and you're taking the diameter down a little bit each pass, you know, in 3 passes. And then how would you clean up that shoulder? Because obviously this turning operation just goes right along the Z-axis, boom. So it's not like you could come in and then back out with a cross slide like on a normal lathe. So that's when you would have your blocks set up here with like a tool that I just showed you back there. You know, you go in and you face it, or you trim the shoulder in, or you cut in a relief, or what have you. So it's just a different way of doing things. But once you figure it out, it becomes easier, way easier each time. I was able to set this job up, and again, I am a complete amateur at this, and you know, and I've only set up like 2 or 3 jobs, but 2 or 3 jobs went from spending all weekend trying to set up the job to, I would say, maybe 2 or 3 hours to set this one up, just dialing it in and getting it perfect. Your drills, right? So these drills, they float, okay? And you know, this whole head right here, it moves left to right. But you would loosen these up. So basically, you know, you would try to find center, you know, so you get it close, and you push it against the work as it's spinning, and you know, the drill will want to find center. And once it does, you kind of just snug up the 2 bolts, back it off, tighten them down a little bit, hit it again, and you know, you'll get it. So it's there, you know, it's not moving. It's just tracking dead center. It's one of those things where you just kind of figure it out, and it's pretty intuitive as you're doing it. So let's see. So the next tool that you gotta figure on here would be the geometric die head. Now this geometric die head, like I was explaining, you know, it has its own little built-in clutch. So when you move the turret and the turret stops, then the die head has a little tiny bit more movement that it will go before it pops out of its own. You know, it hits its clutch and it pops out, and then the chasers disconnect from the work. What I'm trying to get at with all of this is there's these lengths, right? There's a length of travel that this turret will move. And you could see I have like little indications. So when the turret is fully pushed forward, this black line here will meet this face. And this R with the arrow, this is the retraction point. So once it hits right here is when it, you won't hear it, but you could feel it. Once this lines up with the face, it's beginning to retract to the next tool. The art in all of this, and I should say the art of this, is the frustration in this as well. It's a matter of balancing the travel and the length of your tools. Now I know Randy Richard did a really good video on this maybe a month or two ago, maybe 3 months ago, I don't know, it was a little while ago, where he was explaining the same thing. And I think Randy has, quite a bit of experience on the turret lathe. And he kind of like walked you through the correct process, and I found it fascinating because he explained it so well. So if you're struggling to make sense out of my video, you could go check out Randy's. Randy's is really well done. So this is really all a balancing act now. You have varying tool lengths, and you have only a fixed amount of travel that the turret will go. And you have stops in the back here. These are all stops. Each tool has its own stop. You could totally adjust the limit of travel for the turret for each tool. So it's a balancing act of all of that. And then these tools have to clear any kind of tools that you have in blocks over here. Okay, so this cross slider moves a certain amount. And when you're all the way back and you're retracting a tool, let's say this drill is long. And when you retract that drill, if your tool was, say, over here, it could potentially slam into that. And I can't tell you how many times I've set up the whole carousel here, everything is great, and then the last tool hits this tool block. It's like a kick to the stomach. So you gotta kind of like rearrange some tools and sometimes kind of start over again. And these are all the things that you learn as you go along and you do more jobs. Now, one of the things that I did to try to master all this was I totally wanted to strip it down and just do maybe 2 or 3 setups, or 2 or 3 operations. One would be obviously the stop right here, so we could size our material, and the other would be just a drilling operation and then parting off. So that will teach you on how to size your piece correctly, have a tool, and make sure that it doesn't hit a tool that's over here on the block. So this is really just a very quick, high level. I wouldn't even call it an overview, because I'm just babbling on here about how I did this, not the proper way to set up a job. So we're going to, we'll turn on the rotary phase converter. I'm going to set up the camera and I'll show you this in action. All right, first things first, we're going to size up our material. So basically we bring it over to our stop. I'm going to push back on the collet just a little bit to add a little bit of tension. I'm going to bring it in and then lock the collet. And now we're getting ready to center drill. Start up our oil. Now this should be about a 4.5 minute kind of cycle time. Now also what with the turret lathes, you find out how to do a lot of operations in one operation. So not only is the center drilling, but I'm using the angled part of it to produce an inside chamfer. a little bevel. And now here goes our drilling operation. And you get such good feel with this turret. You know, you could start feeling where the chips are starting to get caught up inside the flutes and get a little grizzly. It's all by feel. You know, just keep backing the chips out. And what's nice about the oil is it just, you know, cleans the drill right off. It gets all the chips off of it. What I'd like to have is some of those parabolic drills, you know, for deeper drilling. All right, so we've hit our stop now. Now we're going to do the turning operation. And that's producing these kind of stringy chips here. Another thing I'd like to get is a fatter distributor of oil, like a fatter tip that kind of like will shower it down rather than just put like a one single point on it. So we're just moving along nice and easy, no rush. All right. Lock our die head in place. Put some oil on there. There she goes. We'll hit our stop. Boom. Now we're coming in here back to high speed to do the facing and chamfer. Nice and easy. It's only taking off about 10 thousandths off the face. There we go. We got our chamfer. And now we're getting ready to part. Try to aim it in there a little bit. So I'm going to go in a little tiny bit. Now I want to come in here with my file and just hit that edge, and then hit that edge right there, and then finish off our part. And there you have it. So here's our finished piece, and this is just a little nut that I use to make sure that, you know, to keep the threads honest, because there's a little adjustment that you can do to the geometric die head. Has a little adjuster where you could, you know, bite into the threads or back out depending on what kind of class thread fit that you want. But this is, you know, this is just a general thing, and doing this with one hand so I don't block the camera with my other hand. But yeah, I mean, there's like no slop. It's a good thread, and there's our piece. So that's it for the Hardinge side of things. Now I want to swing over to the South Bend and kind of show you a little bit about the turret stuff that I have for the South Bend. So before we get over to the lathe, I just wanted to show you a quick crude drawing of the print. I don't have the print anywhere. This is all just from memory, but basically we're going to do some lathe work on the South Bend, and we have to turn down this diameter. So this is going to be round stock right here. It's going to begin its life as round stock, 3/4 inch round stock, and then we're going to turn this diameter down. Again, I forget all the measurements. It's really just about the operations. So we're going to turn this portion down. We're going to drill this and then tap it. That's really the only lathe work that has to be done. You know, obviously you got to face this side and you got to face this side. Once all these pieces are done, this will be round, and then I'm going to bring it over into the milling machine and take off that side, you know, mill out that flat, and then plunge an end mill through here, because it's the way the print calls for it. The center of the hole is almost right at this edge, so I'm going to just come in and cut it down with an end mill, you know, and that's the side profile of it. So now we'll take a walk over to the South Bend, and I'll show you. It's not set up yet at all, but I'll just show you basically the turret options that I have for the South Bend. All right, well, no turret lathe is complete without a turret, right? So luckily I've I found a bed turret for my heavy 10 here, which is in pretty nice shape. In fact, I have the bed turret over here. I'm going to show you. I have the cross slide. I have a turret bed stop for the carriage. But you know, just like the Hardinge turret, it's a 6-tool turret, 5/8. Now I have some of the basic tool holders. I just put them in there. I didn't do any setup or anything. But again, this one right here will be to size the material. Let me show you what the material looks like for that job. So this is just 3/4 inch bronze, and they're going to be, you know, there's going to be a little end turn down on there like we just showed in the print. So we'll have the stop here, and then just like I indicated, the operations will have a center drill, and then this one will hold the drill to actually drill it. And now I have this Hardinge TT holder, which is a male tap, same thing as the geometric die head over there on the Hardinge, but basically the same exact thing happens. So when you have a tap in here and you hit the bottom of your hole, it will pull this out. As you can see, this head pulls out, and once it pulls out, it's free, becomes disconnected, and just spins bzzz, like that. And at that point, what you want to do is you want to stop the lathe and then put it in reverse, and it backs out. And then I have 2 tool holders here set up because it's a huge reduction in material. I'm going from 3/4. Oh God, I forgot what the measurement is. About 313 thousandths. So do the math. It's quite a bit of a cut. So I'm going to do it in some stages here, and then I'm going to be doing a combination of turret practices and conventional lathe practices, because I have a cross slide here, so I could kind of just go in and take my final cut and then pull out and cut the shoulder really nice, because I actually have, you know, a cross slide right here. So in some ways this kind of setup is a lot easier than the Hardinge, because you have the functionality of both. And as a side note, this is one piece that I, when I find some time with all the other projects that I have, first I have to finish restoring my shaper and my South Bend grinder, and they need to go over on that end of the shop over there. Once they're done, then I definitely want to do this. This is like a little machine in itself. And then over here we have the cross slide. So this bolts basically to the front of your, where your cross slide handle is. There's some disassembly that's required. You're going to either have a turret lathe or you're going to have a conventional lathe. I'm getting away with both by just using the bed turret. But again, if you want to go full turret, you have to pull out. I think. Again, I haven't even started to look into doing this, but just seeing how this bolts to the front, and there's this gear here, this is going to cause the slider, and I'll show you that. That's right here. Yeah, well, I think that's the place for your nut. So I don't know, but I know that it's not. I don't think it's as easy as just putting this on and doing a job. You got to kind of either be one or the other. But I have everything here to do it, and I don't know. This might actually be cause for another, maybe get another heavy 10 in here, to have as your untouchable conventional lathe and turn this guy into a turret. Because obviously now I have 2 jobs running that are in need of a turret lathe, because this is another high production run. And a reordered run too. They're going to be reordering. The customer's going to be reordering on this one. So, yeah, we got this one going. We have that one going, and I have 4 more in the queue. That's going to be all on the milling machine. So I actually have 3 jobs running. 3 machines running 3 different jobs here in the shop. But that's the turret options over here on the heavy 10. Let's take a look at the headstock end now. Okay, so what you're looking at is something that's been, I would say, in the works for a little over a year now. When I got this machine, I did not have any kind of collet closer. and I really wanted to hold out until I found one of the one of these lever action ones. I do have one that's a mishmash of old style and new style, and I don't know exactly when the new style and the old style, when they came out, when South Bend changed them, but I believe that it has some old parts and some new parts. Maybe not. I'm not 100% sure. But long story short is I had everything ready to go except the side gear. Now this side gear is kind of special because every South Bend has a spindle gear that drives your end gears, okay? When you have a collar closer, you need a different spindle gear. So you take your old one off, you put the new one on, and the new one on is basically the same exact gear, but it also has a sleeve attached to it. And what that sleeve does is it allows this section right here of the collar closer to mate, okay? It goes inside and it locates, and it basically doesn't dangle around. So you're really just extending like a collar off of your spindle. This was a great deal, and it works perfect. It's in nice shape. I'll let you hear it. It's dead quiet. You don't even hear that it's on. You're just hearing the little tick of the belt. And that little tick sound you hear right there is the collar dangling around with nothing in it. But if I lock it, it's nice and smooth. So that's that's it. Finally now I can run collets. I'm very, very happy about that. I've always had the collet nose. I had the knockout nut here. One word on these things. Everybody calls these thread protectors. Now, I am not arguing that they protect threads, because obviously they do. But this is not a thread protector. This is called a knockout nut. And obviously, without it, you wouldn't be able to get the sleeve out without shoving something through the end of the spindle and banging it out. So that's what your spanner wrench comes in, and it knocks this out. So it's called a knockout nut, not a thread protector. So I keep talking about this next job that I'm going to film when I set up the turret lathe. In fact, this will be the one. I will film this when I'm setting it up. So we'll go through the whole process. It's a simple job too. It's it's drilling, turning a diameter, and then tapping a hole. Pretty easy peasy. In fact, I'll probably film the whole process, even on the milling machine side of it too. One of the next videos that I'm going to be doing is kind of a shop update. It's not like an update video where I sit and talk into the camera, but I want to show the methods and the workflow that I've developed in this shop, because the shop came online here in when I came out of the basement. It came online 2016 November. So we're a year and a half up here now, and I just wanted to kind of show how it's changed and how I do things here. I mean, in terms of everything. How do I keep the shop warm? How do I keep it cool? How do I keep the shop clean? Where do I keep the blueprints? How do I, do I take notes on jobs? Repeat orders. Where do I put all the tool? How do I save the tooling and the jigs and the fixtures and stuff like this? Like all these types of different things, I kind of just want to go over and share with you guys. So that's it for now. It's a Sunday night right now in May, and I am heading out for a week of fishing on Lake Champlain, pre-spawn bass action. So I will try to edit some of this footage in my cabin during this week coming up. And when I get back, I'm going to be jumping right back into some work and trying to film. So with that, thank you guys for watching. Apologies for stuff being so sparse, and I'm going to try to get them out faster for everyone. Thank you.